Hi everyone, my name is Amir Basirat and I'm an Analytics Specialist Solutions Architect at AWS. In this quick presentation, which will be accompanied with a demo, I will demonstrate the AWS Game Analytics Pipeline solution that can help game developers launch a scalable serverless data pipeline to ingest, store, and analyze telemetry data generated from games and services. We know the games industry is increasing adoption of the games as a service operating model where games have become more like a service than a product, and revenue is frequently generated through in-app purchases, subscriptions, and other techniques. With this change, it is critical to develop a deeper understanding of how players use the features of games and related services. And this understanding allows us to continually adopt and make the necessary changes to keep players engaged. The solution that I'm going to present here supports the streaming ingestion of data while allowing users to gain insights from their games and other applications within minutes. First, let's look at the solution architecture. We will provide you with a CloudFormation template that you can deploy in your AWS account. And deploying the CloudFormation template with the default parameters builds this environment as you can see here. In fact, the AWS CloudFormation template deploys all the required AWS resources to enable the ingestion, analysis, monitoring, and reporting of game analytics data and sets up the infrastructure to support a serverless data pipeline. Let's further zoom into each of our solutions building blocks and discuss their functionality. Data producers send telemetry data to Amazon Kinesis data streams or to Amazon API Gateway. With Amazon API Gateway, our game analytics pipeline solution launches a REST API that provides an events endpoint for sending telemetry data to the pipeline. This provides an integration option for applications that cannot integrate with Amazon Kinesis directly. The API also provides configuration endpoints for admins to use for registering their game applications with the solution and generating API keys for developers to use when sending events to the REST API. The telemetry data which is sent to the API is then proxied to Amazon Kinesis data streams. The game analytics pipeline solution uses Amazon Kinesis to ingest and process telemetry data from games. Amazon Kinesis data streams ingest the incoming data. Amazon Kinesis Data Firehose consumes and delivers streaming data to Amazon Simple Storage Service or Amazon S3. And Amazon Kinesis Data Analytics for SQL applications generates real-time metrics using streaming SQL queries. The Kinesis data streams also uses AWS Key Management Service or AWS KMS for encryption at rest. The solution also uses AWS Lambda functions to provide data processing, transformation, and validation. For configuration data, we have an AWS Lambda function that provides backend business logic for the solution's REST API configuration endpoints. This function stores newly created game application configurations in Amazon DynamoDB and generates API key authorizations for developers to integrate with the REST API events endpoint. The solution uses Amazon DynamoDB tables to store application configuration data. Each DynamoDB table is provisioned using DynamoDB on-demand capacity to provide flexible scaling and reduce costs for unpredictable access patterns. In DynamoDB, we will have two tables, applications table, which is a table that contains data about the applications registered by data producers and it is identified by application ID. And we will have authorizations table, a table that stores API keys identified by API key ID with a mapping to an application ID. Within a streaming ingestion building block, we have another Lambda function that validates, transforms, and processes input game events from Kinesis Data Firehose before events are loaded into Amazon S3. This function invokes with a batch of input event records and performs validation and processing before returning transformed records back to Kinesis Data Firehouse for delivery to Amazon S3. This function can also be modified to add additional data processing as needed. Then within a streaming analytics building block, we have another AWS Lambda function that processes a batch of SQL results from the Kinesis Data Analytics application and publishes them to Amazon CloudWatch as custom metrics. This function can also be customized to accept different output formats or perform additional processing and delivery to other destinations if needed. The solution uses Amazon Simple Storage Service or Amazon S3 to provide a scalable and cost-effective storage for raw and processed data sets. The Amazon S3 buckets are configured with object lifecycle management policies, including Amazon S3 Intelligent Tiering, which provides cost savings for data sets with unknown or changing access patterns, such as data lakes. The solution also deploys AWS Glue resources for metadata storage and ETL processing. We configure an AWS Glue data catalog. We create an AWS Glue database to serve as the metadata store for ingested data. We deploy an AWS Glue ETL job for processing game events, and we deploy an AWS Glue crawler to update the Glue data catalog with processing results. I should also mention that the solution encrypts the AWS Glue data catalog using KMS. For metrics and notifications, you can use Amazon CloudWatch and Amazon Simple Notification Service or Amazon SNS. The solution uses Amazon CloudWatch to monitor and log the solution's resources and provide a storage of real-time generated metrics from Kinesis Data Analytics. The solution deploys CloudWatch alarms to track the usage of AWS resources and alert admin subscribers when issues are detected. With Amazon Simple Notification Service or Amazon SNS, you can also distribute notifications generated by Amazon CloudWatch alarms when resources are set above thresholds or errors are detected. The solutions admin can also set up notifications for monitoring and troubleshooting purposes. For interactive analytics, you can use Amazon Athena and Amazon Quicksite. Amazon Athena enables you to run queries and reports on the game events data stored in Amazon S3 buckets. You can also set up Athena federated query connectors for DynamoDB or for CloudWatch metrics to extract that data. The solution comes with a set of pre-built saved queries that enable you to explore game events data, and it deploys an Athena workgroup that enables you to create and save additional queries if you want. You can also visualize game data using Amazon Quicksite. You can connect Amazon Quicksite to Amazon Athena to access your game data, and you can create, configure, and customize dashboards for deep data exploration. Okay, let's jump into AWS Management Console so that I can show you the demo and walk you through the process of setting up the environment and the steps involved. Okay, to get CloudFormation template and deploy that CF template in your AWS account, you have to first go to AWS Solutions Implementations page, where you can find details of Game Analytics Pipeline solution. I should mention that all AWS Solutions implementations listed here are vetted by AWS architects, and they are designed to be operationally effective, reliable, secure, and cost efficient. Every AWS Solutions implementation, including the one that we want to implement here, comes with detailed architecture, a deployment guide, implementation guide, and instructions for both automated and manual deployment. Let's launch the CloudFormation template in AWS Console. This solution uses AWS CloudFormation to automate the deployment of Game Analytics pipeline solution in AWS Cloud. You can review the template parameters and adjust them if necessary. The template launches in the US East North Virginia region by default, but you can change that if you want. On the Create Stack box, verify that the correct template URL shows in the Amazon S3 URL text box, and then choose Next. On the specify stack details page, assign a name to your solution stack. I put game analytics pipeline. Under parameters, review the parameters for the template and modify them as necessary. The enable streaming analytics parameter is set to true, and this parameter determines whether Kinesis Data Analytics for SQL is going to be deployed in the solution or not. And Kinesis stream shards is set to 1, which sets the number of shards to provision for Kinesis data streams. Solution admin email address is set to false. You can set that to true if you want to nominate an email address to receive operational notifications generated by solutions resources and delivered by Amazon CloudWatch. The default false parameter here disables the subscription to Amazon SNS topic. And then finally, the solution mode parameter is set to dev. So you can have two options here. You can have dev or prod. Dev mode reduces the Kinesis data firehose buffer interval to every 1 minute to speed up data delivery to Amazon S3 during testing, but this results in less optimized batching. Dev mode also deploys the sample Athena queries and creates a sample application and API key for testing purposes. If you mention prod here, prod mode configures Kinesis data firehose with a buffer interval of 15 minutes and doesn't deploy the sample Athena queries or sample application and API key. So we'll leave it for dev for our testing purposes here and click next. On the configure stack options page, simply choose next. On the review page, review and confirm the settings. Check the boxes at the end, the three boxes acknowledging that the template will create AWS identity and access management or IAM resources, and then choose create a stack to deploy the stack. You can view the status of the stack in the AWS CloudFormation console in the status column. You should receive a status of create complete in approximately 5 to 10 minutes. I stop my recording here and resume as soon as the template is deployed successfully. Bear with me. Okay, we can see that our CloudFormation template is deployed successfully. And now that the stack is deployed, we can navigate to the Outputs tab, where we can see a list of parameters and values that CloudFormation template has generated for us. We need some of these values like game events stream or test application ID to generate sample game events. Let's open the terminal and follow a few steps to generate sample game events. As part of our game analytics pipeline solution, we also provide you with a Python demo script to generate sample game events data for your testing and demonstration. To run the Python script, you must have the latest version of AWS command line interface or AWS CLI. If please install AWS CLI. If you don't have AWS CLI, alternatively, you can also simplify the deployment of this script by using an AWS Cloud9 environment if you want. The first thing that we want to do is let's clone the GitHub location and download the Python demo script first. So this is the first thing that we need to do. Cool. Before running the Python demo script, you have to run a few Python commands to install the prerequisites. Let's first install and upgrade pip for Python 3. Um, Now let's install another key Python tool, virtual environment. This enables you to create a series of controlled environments or local environments where you can install and experiment with Python modules in an isolated environment without upsetting any previously installed software. Let's create and activate the virtual environment now. And let's activate it. Cool. Our solution uses AWS SDK for Python or Bodo tree to interact with Amazon Kinesis. The solution also uses NumPy, UUID, and ArcParse to accept arguments and generate random sample game event data. So let's install those packages as well for our solution. Good. Let's switch to source and demo. And now that we have navigated to this demo folder, we can run this Python command. We need to replace AWS region with AWS region code where the AWS CloudFormation stack is deployed. In our case, it would be US East 1. A stream name, we need to replace that with game events stream from the CloudFormation output tab. So it would be this one. Let's copy the whole thing and paste it here. And then the test application ID, the same thing. We have the value from the CloudFormation output tab. Let's copy and paste it here. Good. Now we can take the whole command and copy and paste it in the terminal. These inputs configure the script to continuously generate batches of 100 random game events for the provided application, and then publishing the events to Amazon Kinesis using the put records API. And as you can see, we are generating sample event data for our game analytics pipeline application. Now we can switch to AWS Management Console and test the sample queries in Amazon Athena. Okay, we can now switch to Amazon Athena service. Select the workgroup tab on top of the page. Select the workgroup named Game Analytics Workgroup and switch to that workgroup from your primary workgroup. With the help of workgroups in Athena, you can separate workloads between users or applications, you can view query metrics, and you can even enforce cost controls if you want. Amazon Athena has also recently announced general availability of a new query engine version, which is Athena Engine version 2, and this is the recommended engine version for your workgroups. Athena Engine version 2 is based on Presto version 0.217, and it introduces a bunch of improvements and new features like support for federated queries, support for nested schemas, and a lot of different performance improvements in terms of query execution and query planning. You can see that our workgroup is currently using Athena Engine version 1. To switch to Athena Engine version 2, I can click on Edit Workgroup page, come down here, and manually choose Athena Engine version 2, which is the recommended engine version, and then save the changes. Okay, Let's go back to Athena. Let's click on Saved Queries tab, and then here we can see the list of our saved queries. We can select one of these existing queries to execute it, and we can also customize the queries if we want. So let's start with new users last month query. So if I run this query, I can get the number of user registrations for new accounts for last month, for the month of November. And you can see that data here. Let's go back to saved queries and choose another query. Let's look at user reported reasons count and run this query. And with the help of this query, we can get a list of report reasons and a count of reports associated with them. Let's look at another saved query, for example. Let's look at level completion rate. Here we can see the completion rate for each level, and you can see that we got the response in 1.44 seconds, and the amount of data scanned by our query is 3.18 megabyte of data. And you can see we get the response very fast. That's pretty cool. All right, let's now test Athena federated query. With new Athena Engine version 2, you can now use federated query to run SQL queries across data stored in relational, non-relational, object, and custom data sources. Athena uses data source connectors that run on AWS Lambda to run federated queries. And a data source connector is just a piece of code that can translate between your target data store and Athena service. So let me show you how you can set up Athena federated query connectors. So to get us started, I will first navigate to serverless application repository, which is our repository for serverless applications. I click on available applications. I make sure that this box is ticked, show apps that create custom IAM rules or resource policies. Then I search for Athena Federation. This is the name of the author that Athena team uses when it publishes connectors to serverless application repository. And as you can see here, it pulled up a list of pre-built connectors here. We have a connector for DocumentDB, for CloudWatch Metrics, for DynamoDB. We have pre-built connector for Elasticsearch, for Elasticache Redis, for CloudWatch connector. And if I go to the next page, you can see a bunch of other connectors like connector for Athena JDBC connector, for JDBC compliant data stores and the Redshift. We have a connector for Athena HBase connector as well. So if you look at each of these connectors, you can see that each of these connectors has AWS verified author badge. When you see that badge, you can be rest assured that the code that you're about to deploy is developed and maintained by the Athena team. Let's first set up a connector for our Amazon CloudWatch events, which makes your CloudWatch metrics data to be accessible using SQL. So I click on Athena CloudWatch metrics connector. When you connect to a connector, you get some information about it, including details of what deploying this connector will do in the form of a CloudFormation template. Further down, you can see what permissions this connector needs. In the case of CloudWatch connector, it needs access to S3 for potentially spelling large responses. And then if you scroll down, you get a more detailed README of what all the configuration options are and how you can use this connector. On the right hand side, we get some of the configurations that we can provide for this connector. We need a spill bucket, so let's put an spill bucket that I've already created for this connector, and this is my S3 spill location. This S3 spill is useful where the response of your request exceeds the capacity of the Lambda. And then you can easily spill this to fulfill your request. Because we tell Athena the spill location ahead of time, at the time we want to set up these connectors, the Athena doesn't need to wait for Lambda function to complete before it can go and get that data. Athena can prefetch and watch that S3 location, and as soon as data arrives, it can process that. Then we need a catalog name. Athena catalog name is in fact the function name or the name you will give to this catalog in Athena. Let me put CloudWatch for my catalog name. Spill location is also encrypted by default. Um, you can disable that if you want. And Lambda memory and Lambda time at values, let's leave them as default values here as well. You can also specify a prefix within spill bucket for your Lambda function. Let me put a CloudWatch prefix for my CloudWatch spill data. And then I tick this box. I will check this box that gives serverless app repo permission to create the scoped down IAM role um, that connector needs. And then I deploy the connector. And this process can take 1 to 2 minutes depending on the complexity of the connector setup. So let's wait for a few seconds. Hopefully the connector gets deployed very fast. We can check the status of the deployment here. You can see that the deployment has already started. The creation is in progress. You can also check the status of this deployment in CloudFormation. We should have this Lambda connector deployed very fast. And then when this Lambda connector is deployed, we can go back to Athena and run our federated query for CloudWatch metrics data. Okay, the connector is deployed. Very good. Let's go back to Athena service and run our federated query for CloudWatch metrics data. This query lists CloudWatch metrics where our namespace is pointing to Amazon DynamoDB. We should get the results back in a few seconds. Cool. Very good. We can also set up another Athena federated query for DynamoDB if we want to extract our application configuration data from applications table or authorization table. Let's do that quickly as well. We go back to serverless application repository. Again, we search for Athena Federation. We look for Athena DynamoDB connector and we fill in the parameters. So again, our spill bucket is the same spill bucket that we use for our CloudWatch metrics connector. For catalog name, we can put Dynamo here and leave the default values for spill encryption, for Lambda memory, and for Lambda timeout. For spill prefix, I can also set this prefix to be Athena spill Dynamo. And then I acknowledge and I deploy the connector. Let's wait until this connector gets deployed as well. Again, we can check the status here. Creation is in progress. You can see that if I go back to DynamoDB service, you can see that in DynamoDB, as I explained before, we have two tables. We have applications table and I have authorizations table, so I can run my federated query against each of these tables. Let's go back and check the status of our connector. The connector is already deployed. Very good. We go back to Athena now. And this time we run a federated query against DynamoDB data store. So I'm running this query against Game Analytics Pipeline applications table. Very good. I can get the data from DynamoDB as well. Okay, now let's connect Amazon Athena to Amazon Quicksite so that we can access game data and create, configure, and customize dashboards for deep data exploration. Okay, I navigate to Amazon Quicksite. I choose admin from the upper right corner. I select manage Quicksite. I select security and permissions. Under Quicksite access to AWS services, I click on add or remove. Let's select Amazon Athena, click next, click finish. We also need to select Amazon S3. Select the game bucket resources that are created earlier by AWS CloudFormation. In the right permission column, select the checkbox next to Athena workgroup. And with that, we are going to provide right permission for Athena workgroup. Click finish and select update. Now we select the Quicksite logo in the top left corner to navigate to Amazon Quicksite console. Select datasets, choose new dataset, and then choose Athena. Um, in the new Athena data source dialog box, we need to enter a name. Let's put Athena Game Analytics Pipeline. In Athena workgroup field, let's select the workgroup named Game Analytics Workgroup and then validate the connection. After the connection is validated, choose Create Data Source. In the Choose Your Table dialog box for database field, select the database that was deployed by AWS CloudFormation. And when you select that, a list of available tables will populate. Choose Row Events and then choose Select. On the Finish Dataset Creation dialog box, select Directly Query Your Data and then choose Edit Preview Data. Good. We can now see the preview data. Let's create a calculated field. We select Add Calculated field. We create a name. For example, we put level ID. And in the formula field, we enter the formula, the parse.json formula for level ID, and we choose Save. You can also repeat these steps to create calculated fields for each data type that you want to extract from event data. Now to build the Amazon Quicksite dashboard, we again navigate to Amazon Quicksite console. This time we click on Analysis, New Analysis, and we choose our data set, which is row events, and then we create analysis. A new sheet with a blank visual will display. In the visual types pane, let's select, for example, line chart. And Amazon Quicksite will create the visualization for us. From the fields list, let's select event timestamp time format. And let's drag event ID as well as event type. Now for our event timestamp time format, let's select the drop-down arrow next to that and change the aggregate from day to, say, minute. And we can also change the name of our sheet to count of events. Very good. We can also add another visualization here if we want, and say, for example, drag and drop event type, or change visualization as we need. Um, so as you can see, Quicksite can help us create meaningful dashboards and a very powerful tool for deep data exploration. I've also created a number of other dashboards for our game analytics pipeline application that you can see here. And as you can see, you can utilize QuickSight to create a very powerful dashboard and visualization for your data exploration purposes. Fantastic. Okay, now that we have seen the demo, let's quickly discuss the features of our game analytics pipeline solution. Game developers can now create a scalable serverless data pipeline in AWS to ingest, store, and analyze game data generated from different services. You can organize and structure data in Amazon S3 to provide data lake integration and configure AWS Glue to catalog metadata for your datasets. You can gain insights from games and other applications within minutes from the streaming ingestion of data, and you can also customize the solution to fit your particular needs. For example, by editing the solution API and adapting the processing workflows and real-time streaming analytics application if needed. I hope this quick demo was useful for you to gain a better understanding of how you can utilize various AWS services to provide a framework for ingesting game events into your data lake for analytics and storage. You can find more information about our game analytics pipeline solution by checking our AWS Solutions implementation page. And as I explained before, you can also find a CloudFormation template to build a solution along with detailed implementation and developer guides. Thank you very much for your time and stay safe.